We're going to now, I'm going to do a tutorial on electron configuration. And just to keep in mind, electron configuration is being able to identify the element based on where its electrons are. And, of course, vice versa. By finding an element, you know exactly where the electrons are. So just a quick review. Remember that we have an atom, and an atom has a certain number of protons and neutrons in its nucleus. And then you have the electrons on the outside, and I've been using negative markings. The first shell holds 2 electrons, and then we've been saying that the second shell holds 8 electrons. Okay, and now we're going to take a closer look of what that actually means based on the periodic table. So here I have a periodic table. You'll notice that it has the atomic number, but it doesn't have the elements, just in consideration of space. So take out your own electron configuration paper, and you'll notice it has a similar structure. So just quickly, we have here our rows, and these tell us how many shells we have. So the first, any atoms over here contain 1 shell. Any atoms over here contain both 1 and 2 shells, so a total of 2. These here contain 6 shells, any of those elements, and these elements contain 7 shells. All right, again, here we have our periods going down, just as a refresher. And these tell us how many valence electrons we have on the outside. And we already know that if you're in group 7, you have 7 valence electrons. If you're in group 4, and better said, an element is in group 4, you have 4 valence electrons. So it's a way of seeing how many valence electrons there are. All right, next one. This area right over here, we call the s orbital. All right, so going back to our picture from before, that is the first, here's our nucleus. This is our first shell. The first shell is called the S shell, okay? Oops. There we go. Then you have the next shell being the P shell. Then you have the D shell, and then you have the F shell, okay? So let's say we want to write down the electron configuration of something. Here would be an example. All right, so here we have an electron configuration where it's 1s1. Remember, this tells you what row that electron is in. This tells you the group that it's in, more or less those vertical down, and this tells you what the subshell is. So 1s1 is going to be, let's go back to 1s1. It is in the first row, so there's the first row. It's in the s orbital, and it's the first one. So we have hydrogen having the electron configuration of 1s1. Let's maybe try number 27, which is cobalt. Let's see if we can do an electron configuration for cobalt. And remember, you read it as you read a typewriter. So we're going to start here. These are the electrons that you find in cobalt. The first electron is 1s all the way to 2. so we know that it goes all the way across. Then we have 2s2, okay, because it fills all of those. Then we have 2p6, goes all the way across, 1, 2, 3, 4, 5, 6. It's in the second, it's the second shell. The p is the subshell, and past we have 6 electrons in there. Then we have 3s2, because we're moving across here. Then it goes 3p6. Then next we're going to have 4 s2. Okay. Then we have, in this case, 3d and 1, 2, 3, 4, 5, 6, 7. All right. And this is the electron configuration for cobalt. That's where we're going to end it.